Dear students, good morning. Today we are going to see about deep learning and its methods, models, and how it is going to be analyzed. All those things we are going to see in detail about in this video. Here before we have discussed about the what is neural networks and what are the types of networks. We have seen about the neural networks types, right? That is feed-forward neural network, CNN, that is convolutional neural network, RNN, what it is, that is recurrent neural network, and GAN. Okay, so those and those types we have seen what are the accessing methods and what are the logics behind that. All those things we have covered in the last videos. In here we are going to see in detail about the technical foundation behind this neural networks, what exactly. So here, that is the neural networks, we can have the categories as a three, that is structure of a neuron, layers and architecture, activation functions. Okay, these are the three categories we need to have in a neural network while designing. Structure of a neuron, this structure of neuron consists of the input signals, weights, bias, and activation functions. So this is how the structure of neuron could be. And previous videos we have seen about the diagrammatic explanation also. Now we are next coming to the layers and architecture. In this layers and architecture, we could have that input layer, hidden layer, output layer, and types of architecture we may have that the feed forward, recurrent, and convolution, and so on. Okay, and coming to the activation function, we have several logic function we have, that is the one does usually have the that is frequent usage, that is sigmoid function, tau function, ReLU is rectified linear units of softmax function. Based upon the application and complication of the problem, the activation function will be different. Okay, so this is how the neural technological foundations of the neural networks is mainly categorized as structure. We could concentrate as a structure, layer, and architecture, and activation function. So coming next, the training algorithm. In a neural network, how the training algorithm is taking place and in for what metrics it could be. First, we could consider that is gradient descent. Okay, and back propagation, optimization techniques, loss functions. So these are the main metrics we can have while considering the training the algorithms. Okay, so first in this training algorithm, gradient descent, learn the following parameters we may consider, that is learning rate, cost function, batch gradient descent, stochastic gradient descent. While considering the problem and based upon the weightage of the problem, the gradient descent will be optimized. Okay, and coming to the back propagation, we all knew we need to do the iteration process till the outcome, that is expected outcome, how to reach. So while doing the back propagation, we must aware and we have to concentrate about these metrics, that is error calculation should be done, weight adjustment could be made, chain rule application, and bias update. So then and then we have to do the bias updation also while doing the back propagation. And coming to the optimization techniques, these techniques are used to enhance the neural network performance. And in this optimization techniques, what are the metrics how to follow? Here it is momentum, that is ADAM, we can call it as a acronym, that is ADAM, that is adaptive movement estimation, and RMS pop, that is root mean square propagation, and nestro, that is accelerator gradient. So these are the metrics we could consider while doing the optimization techniques. For what this optimization, that is it will enhance the performance of the neural network without loss. And also we have to consider about the loss function. In the loss function, we need to concentrate about these parameters. What is the mean squared error? We all knew very well about mean square error, cross entropy loss, and hinge loss, and mean absolute error. So we should be more focused of these parameters: mean square error, cross entropy loss, hinge loss, mean absolute error. So this is how we have to be choosy while doing the training algorithm, how to concentrate all about this metric before opting the training algorithm. And coming to the model evaluation, so once we made the technical foundation, after that the training algorithm selection we made, after that model evaluation, how our model is going to be evaluated based upon the performance metrics, overfitting and underfitting, validation techniques, regularization methods. So this is how the model is going to be evaluated in the neural network. Okay, and first we will see the performance metrics. For while doing the performance metrics, what are the things we need to analyze? That is accuracy, precision and recall, fi score, roc, auc curve. So these are the main thing while doing the performance means what? That is the result and deliverables are can have the outcome. Okay, so it must consider about the metric, that is accuracy, precision and recall, FI score, ROC, that is AUC curve. So coming to the overfitting and underfitting, that is what is overfitting and underfitting. There may be a boundary, and within that boundary, we should accompany the whatever the task or whatever the problem is given based upon the algorithm what we opted. Okay, so in overfitting and underfitting, we need to have the causes of overfitting. What are the causes it is created the overfitting, and also have to analyze about what are the causes of underfitting, and decision, that is deduction methods, which method we are going to use for finding the overfitting and underfitting. We may have then the classification methods like PCA, the probabilistic PCA methods, all those things we have in the overfitting and underfitting. Okay, so likewise prevention strategy, if we found that, how we are going to prevent it, that is prevention. We all knew the proverb that is prevention is better than cure. That is why here, well, after problem happening, the action taken will be good, but prevention is more fine before that. So how to consider this prevention strategies also to avoid this overfitting as well as the underfitting. Okay, coming to the validation techniques, so we made the performance metrics and overfitting underfitting analysis, and how we are going to validate the technique based upon this, that is hold out validation, k-fold cross validation, leave one out cross validation, stratified sampling. So these are some algorithm and some logics is behind to validate the technique in an efficient manner. And coming to the regularization method, how it is going to be regularized, we have the for types of methods to regularize this neural networks, that is L1 regularization, it's also called a lasso, and L2 regularization, it is also called a ridge and dropout and early stopping. So this is how the performance metrics, overfitting, underfitting, and also validation technique, regularization technique is evaluated in the model. That is when before going to release the exact thing, the model evaluation could be done in the neural network to analyze the effectiveness of the model. Okay, so still now we have discussed about the technical foundations of neural networks, the structure of neuron layers and architecture, activation functions and training algorithm, what are the main metrics we could consider while choosing the training algorithm, and how the model is going to be evaluated, the main parameters we are discussed in detail here. Thank you for your passion listening.